My name is Loke Dupont. I'm a solution architect working for TV2 Denmark in the Streaming and PLAYOUT team. I'm here to give you some insights on how we improved our live-to-VOD workflows. For a bit of context, let me briefly describe who TV2 Denmark is. We are a publicly owned commercial broadcaster, meaning we are owned by the Danish government, but we run on commercial terms and get no public funding. We have traditional distribution by cable and IPTV providers or even through terrestrial broadcast. But our strategy the last few years have been on growing our direct-to-consumer brand, TV2 Play. For this we have 800,000 customers in a country of just 5.8 million people. That's quite a lot. Now let's define what we mean by live-to-VOD and what we're trying to accomplish here. We define live-to-VOD as any viewing of a program that was broadcast live after it was aired, whether that's a minute after it's broadcast or 2 weeks after or months after. This doesn't include the case of time-shifted viewing like start over functionality that's available mid-broadcast. This is not our first live-to-VOD system we are designing here. Depending on how you count it, this is the fourth or fifth iteration actually we're working with. From those iterations and from the product manager requests and feedback we've gathered, we have a number of requirements that we want the new system to live up to. First requirement is that we have to have the content available for viewing on the platform within 1 to 2 minutes after broadcasting it. Ideally, this would be instant, but we don't think that's currently doable with our platform. Not necessarily because of limitations in the streaming technology we're using here, but just as much because of caching in the video platform APIs that make it tricky to surface the content when available right after. We also want to avoid having to maintain a separate origin forever, because the live-to-VOD assets are based on a specific origin software. One of our previous iterations of live-to-VOD systems here were bound to a specific origins implementation of capturing live-to-VOD assets, and needed the same exact origin to play back. This is a dependency we don't want to have and we want to avoid in the new system. Previous solutions we had were based on standard workflow software, which always ended up messy to maintain and requiring very specialized knowledge. This felt like a dead end to the engineers working on it and made the system hard to update. Instead, we wanted to use standard components and building blocks of the cloud vendor that we normally use, AWS. We naturally want these live-to-VOD clips to be frame accurate and look as if they were VOD programs that were captured as VOD. We want to avoid having the clock for news channels that's in the corner there normally. We also want to avoid having on-air promotions and teasers for other programs in the VOD assets that we create for live-to-VOD. It should also not require manual work to maintain the live-to-VOD systems. For instance, we want to record and publish programs automatically if we know they should be, and we don't want to require setting manual in and out points for the programs if we can avoid it. We also want to allow manually marking it for publication both before and after the broadcast. Last thing we have on our requirement list here is we don't want to use as-run log files as the basis for the live-to-VOD system because we sometimes see problems with how these files are written, or they might not be written as quickly as we would like. For those unfamiliar with what as-run log files are, they are logs of what was played on the channel, basically the channel playlist, and it's writing the log of when it broadcasted each individual program. They're literally logs of the channel as run. They also make it really hard using those to ensure frame accuracy with the video because we only have the timing of the logs independently of the video signal we're getting. So where did we start with this project? We started by looking at how things are actually broadcast in order to better understand how we can get the information we need about when a program starts. At TV2, we use a playout system by Pebble Beach named Marina. This system controls the video being broadcast by switching actual SDI signals and controlling a vision mixer, graphics inserters, and a number of other parts of the broadcast chain. This means the only place we could really get that necessary data to automate live-to-VOD is Marina. Previously, we've been using as-run logs that Marina writes, but as I mentioned, those have several drawbacks that we didn't want to have. We wanted to make sure that we had the data about programs in sync with the video signal to the point where we get it to be frame accurate and cut these accurately. This is when we remember that we already had a very similar requirement that we use for other cases. This was for live ad replacement. For live ad replacement, we do this by inserting Scotty 104 splice insert messages controlled by Marina. Since this automatically has synced between the video and data messages because it gets to us in the same SDI signal, we started to look at this and figured we could reuse the same mechanic and insert time signal messages with the program IDs. Lucky for us in this case, Marina already had the transmission IDs that we needed, known as reconciled keys, from our system that contains program metadata and linear scheduling information, a system called What's On. because we also want to have a version for Light to VOD that's clear of any unrelated graphics such as a new scroll and clock, references to upcoming programs. We have a separate live production pipeline set up specifically for Light to VOD that doesn't have these additional graphics inserters, but instead has an extra Scotty 104 inserter for the time signal markers that we need to capture Light to VOD. We now have a SDI signal with Scotty 104 signaling. Time to convert this to something we can use in the streaming space more easily. We do this by using a number of AWS elemental live encoders that output HLS. The elemental encoders are converting the Scotty 104 to Scotty 35 and inserting markers in an HLS manifest. We also got a bit lucky here that elemental will actually break the segments on Scotty 35 signaling, which will make it easier to process this for us. In addition to sending the HLS output to a S3 bucket, we are also sending the M38 manifest every time it's written to a Lambda function via API gateway. This will then look for Scotty 35 markers and new segments and start processing those. It does that by triggering step functions, workflows that do the underlying work of capturing the different segments and concatenating them, as well as marking and storing the data about Scotty 35 markers that we receive. If we take a look at an example manifest, it becomes clear just how useful the signaling of these markers is. In line with the segments, we get a marker for each program start, along with actual data of the Scotty 35 time signal marker that's inserted. We now have a clear picture of which segments we need to concatenate to make a complete VOD. When we get the Scotty 35 markers, we also store the exact timing of the received markers for other uses. And as you can see here, we have a clear program start and clear program end, and we can basically just capture the segments in between those markers. With a running manifest of Scotty 35 markers with segments in between them, it becomes a very simple operation for us to concatenate those segments between start and end markers. For multiple programs such as football matches, ice hockey, etc., we can then concatenate those two separate parts that we create from each individual part of the program, and we end up with a completed VOD program without the breaks in between or any sort of half-time entertainment. We then send the program to our normal publication pipeline that creates an ABR set, packages it for our origin servers, and notifies the video platform of the newly available assets. This way, we don't have to maintain a separate origin as we've done previously, because it behaves like any other VOD asset from the point where we receive the concatenated MPEG-2 TS file and send it through the supply chain and package it and so forth. This makes it very, very simple because it behaves like any other VOD asset that we have on the platform today. Light to VOD in most cases for us is completely automated, and the way we achieve that automation starts with a central system at TV2, namely What's On by a company called Mediagenics. What's On stores information about all the content we have licensed, including rights and metadata. It also contains information about all the content we produce, including any live transmission. Producers then use What's On to schedule live channels and also schedule what gets published on TV2 Play. Linear schedules are exported to the PLAYOUT system Marina that we already mentioned, containing the reconcile key, which also gets transmitted in the Scotty 35 events that we receive. With the Scotty 35 markers in the HLS manifest, we can then do a lookup of the reconcile key and determine which content it refers back to. If we can find an on-demand publication for a live program, we will automatically mark it for Light to VOD. The selection criteria for marking programs for Light to VOD is then, is the program live? Do we have the rights to use this on demand? Is there a publication for on demand on this program? If all three of those criteria are met, we automatically mark it for Live to VOD. This means our editors do not need to manually mark things, they just have to make sure it's published for on demand on the platform, something they're doing anyway in order to publish it. If we already have received VOD objects as video files before Live to VOD happens, then of course we don't do Live to VOD because we already have a clean copy that we can use. Should they need to export something we haven't automatically marked, they can do so from the Live to VOD interface. They can do that both before and after broadcast. It also allows them to export it with a new content ID in case the content IDs for that particular program has changed. It's not often, but it happens. Eagle-eyed viewers will now of course note that this can't possibly have the asset available on our platform within 1 to 2 minutes, which was one of the requirements we had earlier. That's totally correct. This process takes somewhat longer, but still completes in under 10 minutes for 2/3 of all programs that we have. It can take even longer for content where encoding acceleration fails, or just very long programs like Tour de France or other programs that takes 5, 6, 8 hours. How do we then get to 1 to 2 minutes availability? Well, let's take a look at the same diagram we used earlier with a timeline. What we do is look for the Scotty 35 marker in timing, and then we publish a virtual VOD asset that's basically pointing to the live buffer of the normal origin service we use for live, with timings we got from the Scotty 35 markers in the separate HLS live VOD streams. This will return a slightly inaccurate representation, as the origin will have to break the long existing segment lines to create these assets, and will therefore be up to a segment off from the timing we give it. But we can live with that until we publish the actual VOD assets that are correct. Once the VOD asset is ready, it will get transparently published and replacing the already existing virtual VOD asset, and new users will simply get the nicer version with all the extra graphics, and that's completely frame accurate. This way we are sort of getting the best of both worlds. A slight limitation of the system currently is that we won't publish virtual VOD for when the second or third part of a multi-part broadcast, like sports with multiple parts, is ready. This is because our origin doesn't allow concatenating things in the live buffer. We can't give it 2 inputs and 2 outpoints and then say concatenate this to a single asset. That's a limitation that we currently have. Sometimes, of course, these automatic triggers that we get aren't available, or they might be inaccurate. For instance, when producing soccer matches, the playout system isn't the one switching between studio commentators and the match. The playout system will likely just see a single feed coming in for the venue for the whole thing, and the individual cuts between the studio and when the match starts is done by producers at the venue. In this case, the continuity producer might not mark the transitions between those two things as exactly as we would like. For use cases like this, we build a simple cut and publish tool that allows the editors to view the VOD, including time before and after these in and out points. Since the live to VOD feed is HLS, it's fairly easy for us to simply reassemble a HLS manifest that contains the program along with time both before and after it, and allow the producers and editors to set new in and out points that we then use to publish a new live to VOD assets from. Depending on where we are in the timeline, if for instance we're still in a virtual VOD stage, we will publish a new virtual VOD, or if we're already transitioned to an actual VOD asset, we'll just wait until that actual VOD asset with more accurate cuts are published. Before this, the editors would have to start up AVID, grab the live stream data, cut it, and then wait for AVID to export the actual cut of that. That then would go through the normal supply chain and gets packaged and encoded and so on. This was a much slower workflow that significantly delayed the publication of the new live to VOD assets. So, how did this new improved system do? Well, we've had several big sporting events since the initial launch of the system and handled them all without issues. This here is a non-exhaustive list showing several types of sports. For instance, we have cycling, we have handball, we have football, and we also have Wimbledon. But just as important for us is the daily news broadcast, as this is one of our unique points when comparing us to Netflix or Discovery. We're the only 24/7 news station in Denmark, and we're using the content from that to deliver fresh content on our platform that's important to distinguish us from the competition. When talking to our editors about this new system, they're quite happy with the output, and when we get accurate markers, the system is actually frame accurate to within ±1 frame. That's good enough for us, at least. If we go by the numbers, we run a total of 31 total channels with live to VOD with this system. Normally we see 200 to 250 transmissions per day, but during summer sports, we've seen events up to 300 transmissions per day. 40 to 60 of those are normally published to our streaming service as live to VOD assets. Recordings we see are generally within 2 minutes to 5 hours in length, averaging 45 minutes, with far most of them being under an hour. The longer ones are relatively rare. The longest recording we've captured so far is 18 hours. This system was launched back in February of this year and have been running for 8 months since that without issue. We've of course continuously updated the system with new features such as the cut and publish mechanic. This system has also given us a new and robust live to VOD system, and it turns out some of the data we collect is also beneficial for other things that we get as a sort of side benefit. We now collect accurate timing for programming that can be used for these other cases. The only other place to get that information previously was our PLAYOUT system, and there's some hesitation to allow constant API requests to a system that, if we overload it, might actually result in not actually having any video on our broadcast channels. Instead, we now have the live to VOD system that can deliver these timings just as good as the PLAYOUT system can. And if we look here at this example, we have a planned transmission start off that's off by 21 minutes from the actual transmission start. With the new live VOD system, we can basically take these adjusted timings and use them for something like start over functionality, where you want to start from the start of a broadcast while it's still ongoing. We can also use it to update our EPG with more accurate data, so it shows the EPG data onto the actual live broadcast that's correct and showing what you're actually watching. It also allows, while updating the EPG, to give us more accurate data for reporting tracking for Nielsen or whatever tracking is used for handling how many viewers are watching each individual program on the platform. This system, of course, has been great, but we also have things we want to improve. For instance, we want to be able to better handle virtual VOD for multi-part broadcasts, so sports events where we have part 1 and part 2, or part 1, 2, and 3, with parts in between that we don't want to have. Today we are only publishing virtual VOD for the first part, because we can't publish virtual VOD for all the parts due to a limitation on the origin where we can't give it multiple in and out points and concatenate those in the live buffer. Hopefully we can find an origin that can do that, or our existing origin can be updated to support this. We also want to get better signals for broadcast where the switching between sources isn't controlled by the PLAYOUT system and the continuity producer. This will likely mean integration with the news production systems that are being used for news broadcasts, where it's being switched at the news production side and not by the continuity producer, as well as integration with sports broadcasts at the venue where they're switching those things. We are still likely to see at least some cases where there isn't any automated accurate timing though, and we still need to adjust it, but we'll try and minimize those. We also want to allow our editors to adjust the endpoints of the broadcast while it's still ongoing. This would allow us to publish a corrected asset sooner, where we have accurate endpoints from the beginning when we first publish it to the platform. This was an overview of our new live VOD system. Thanks for listening, and if you have any questions, feel free to send them to me at lodu@tv2.dk. Thanks.